Welcome back, Calculus. Today is going to be the first part of the related rate section. I broke it up into 4 parts. Today we're just going to solve some simple related rate application problems. So if you look at this example, we have a ball being kicked into the air. And want to know what does these three different notations mean. dy dx is the change in y as x changes. The x dt is the change in x as time goes on, so it's the change in the horizontal position as time changes. dy dt is the change in the height as time changes. Okay. So we're going to need implicit differentiation here, recognizing what those rate of changes mean. The edge length of a square is increasing at a rate of 3 meters per second. What is the rate of change of the area of the square when the edges are 5 centimeters and 11 centimeters? Let's do that one. So we have a square, and the edge lengths are changing. I'm going to call the edge lengths S for sides. Now the rate of change of the sides is 3 centimeters per second, so they're getting bigger at that constant rate. So the rate of change of the sides as time is changing, it's increasing, so it's positive, 3 centimeters per second. We want to find the rate of change of the area over time when the sides are 5 and 11. So we need to find a relationship between area and sides, and the relationship between area squared and the side lengths of the square is area equals s squared. Now I want to find dA dt, so what I can do is differentiate both sides with respect to time. So the derivative of the area with respect to time is dA dt, that's the implicit differentiation. And the rate of change of the side of s squared is 2s ds dt. All right. So when the side length is 5, dA dt is 2 times 5 times ds dt, which is 3, which is 30. So when the side length is 5, the area is changing at a rate of 30 square centimeters per second. When s is 11, dA dt is 2 times 11 times ds dt, which is 3, which is 66 square centimeters per second. Right? And so that is a related rates problem. The general steps here, you pause the video and copy them down. Make a diagram, label the relevant information, define in calculus terms we need to find, in that case it was dA dt. Determine a formula that relates the information you have with the rate of change you're trying to find. Differentiate with respect to t, and then substitute and solve. In this example, we're dropping a pebble into a pond and watching the ripples move outward in a circular pattern. You estimate that the ripples are moving outward at a rate of 2 feet per second. How quickly is the area of the ripples changing when the radius is 12 feet? So you get kind of like this circle here, and then when you drop a pebble into the water, it gets bigger and bigger and bigger and bigger. We want to find the rate of change of the area. And we know that the rate of change of the radius is 2 feet per second, and it's positive. So now we need to find a relationship between A and R, and the area of a circle is pi r squared. And now we can differentiate both sides with respect to t. So dA dt is going to be 2 pi r dr dt. And we want to find out what is dA dt when the radius is 12. So we can just substitute and solve. 2 pi times 12 times dr dt, which is 2. It's going to be 48 pi square feet per second. Anyway, so that was just kind of the basic version of some of these related rate problems. In the end, they all kind of follow this general steps of make a diagram, label the information, define what you're looking for, relate the variables to each other, differentiate, substitute, and solve. But that's it. Have a great day. Make sure to like, share, and subscribe. Ring the bell for notifications. And if you have any questions, I'd love to hear in the comments.